Bismillahirrahmanirrahim. Assalamu alaikum. Today we will start chapter number 6. The title of chapter number 6 is Ordinary Differential Equations, abbreviated as ODEs. So whenever we say that ODE, so it means that ordinary differential equation. To understand the idea of differential equations, first of all we need to define differential equation. So equations involving derivatives or differentials are called differential equations. For example, this is an equation. Because of this equality, this is an equation, and this equation involves derivative of y with respect to x. Derivative of y with respect to x. So this equation is called now differential equation because this equation involves derivative. And if we look at this side, this is d of y. D of y means differential of y, and d of x means differential of x. There is a little bit difference between differential and derivative. Anyways, this is differential of y and this is differential of x, and this is an equation. So this equation involves differential of x and differential of y. So that's why this equation is called differential equation. Secondly, there is a notation. Notation is y prime. Y prime, or you can say that y dash. Y prime is actually derivative of y with respect to x, or whatever the independent variable is, but that is y prime, this y prime. So whenever we say y prime, it means that that is the derivative of y with respect to independent variable x. And if you look around here, this is dy by dx or dy dx. So dy dx is actually y prime. This is y prime, and in this y prime you see that this y prime includes x as well as y. So we say that y prime is the function of x and y. So that is y prime is the function of x and y. So that is a notation. Wherever there is y prime, so it means that that is actually function of x and y. So function of x and y is actually y prime, and y prime is actually function of xy. Remember this notation because this notation will be used throughout this chapter. Y prime is function of x comma y. Now thirdly, we have defined differential equations, and now we are going to define solution of ODE, solution of differential equation, solution of ordinary differential equation. So solution of ordinary differential equation, if we are able to remove this derivative from this equation, so that will be the relation between y and this whole side, and this whole side contains x and y. X is actually independent variable and y is said to be dependent variable, and y is dependent upon this independent variable x. Solution of ODE means to find the relation between dependent variable y, the relation between dependent variable y and independent variable x, free from derivative or differential, free from derivative and free from differential. So when we solve this equation, it means that we need to remove this derivative or we need to remove these differentials and to get an equation which is free from these derivatives and these differentials. So that is called solution of differential equation. Next is order of ODE. What is the order of differential equation? The order of differential equation is defined to be highest derivative involved in ODE. That is ODE, that is actually differential equation, an ordinary differential equation. And in this equation we see that that is the first derivative of y, and this is the second derivative of y. So the highest derivative is second, so this second, I mean this 2, is the order of this differential equation. So for order we need to check the maximum derivative in the equation, not the maximum power but the maximum derivative. That is the order of differential equation. Now the next is degree of differential equation, or you may say that ordinary differential equation. So degree is a bit different from order. For degree we will check the highest derivative. So whenever you find the highest derivative, note the whole power of that highest derivative. In this equation we see that the highest derivative is second one, and in this second derivative the whole power of this second derivative is 1. So we may say that the degree of this differential equation is whole power 1. So the power of highest derivative is the degree. The power of highest derivative is the degree of differential equation. For example, that is the same differential equation, this one, and we see that the maximum derivative is y double prime, and the whole power of this y double prime is 1. So that's why the degree of this differential equation is 1. So that is the difference between order and degree. These are some initial points for this chapter. Actually we are interested in the solution of ODE, but for the solution of ODE we are dealing with numerical techniques, because we are studying numerical analysis. So we are interested in numerical solutions, and numerical solutions are actually approximate solutions, not the exact solution. So remember that whenever we are talking about the numerical solution of differential equation, it will mean that we need to find the approximate solution of differential equation. So let's come to the original topic, that how could we solve differential equation, especially ordinary differential equation. So that is the next slide. Numerical methods to solve ordinary differential equations. Numerical methods. We will be dealing with all these numerical methods to solve a differential equation. So what are those numerical methods? The first one is Picard's method, and Picard's method is also called successive approximation method. The second one is Taylor series method. The third one is Euler's method. The fourth one is Runge-Kutta method, abbreviated as RK method. The fifth one is Milne-Simpson predictor character method. The sixth one is Adams-Bashforth predictor character method, and the last one is Adams-Moulton predictor character method. The last one is also called the modified form of Adams-Bashforth method. So we will be dealing all these methodologies in order to find the solution of find the solution of ODEs. So these methods will be used to find the solution of ODEs. So let's come to this method, Picard's method, or successive approximation method, that how could we use this method to solve ODE. So that is the next slide. In this slide we will study that what are the major steps for Picard method to solve ODE. The first one is, you will be given a differential equation. the first order differential equation y prime, and we have just studied that y prime is actually function of xy. So function of xy or y prime will be given to you people, and the starting point from which we will be starting our problem, that is called the initial guess, or we may say that initial approximation. So initial approximation will also be given to you people. Initial approximation is actually the value of x and the value of y for n is equal to 0, x naught and y naught. So separately they may also be given to you people just like x naught and y naught, or this x naught y naught may be given in this style: y of x naught is equal to y naught. It means that the value of x is x naught and the value of y is y naught. So just look at this thing: y of 0 is equal to 1. Y of 0 is equal to 1. It means that if you compare this y of 0 is equal to 1 with this notation, so we will get x naught is equal to 0 and y naught is equal to 1. So x naught is equal to 0 and y naught is equal to 1. That is the second style for initial approximation. So initial approximation will be given to you people, and thirdly, which is the major step of this method, is actually the general formula for Picard's method, and that is the formula for Picard's method: y of n. This n may be written in the base of y, because this is approximation, not derivative, but this is not actually the nth derivative of y. There is actually approximation: y of y naught when n is equal to 0, y1, y2, y3. You can also write this n in the base of this y here. Anyways, so yn is equal to y naught plus integral from x naught to x, function of x comma y of n minus 1. That is the n minus 1th approximation of y, and this is the nth approximation of y, where n is equal to 1, 2, 3 and so on. So this formula will be used to find approximations in Picard's method. So if you want to find the first approximation, you need to replace n by 1, so that will be y1. If you find the second approximation, you need to replace n by 2. For third approximation, you need to replace n by 3 and so on, where n denotes number of approximations. This n denotes number of approximations, and x is equal to this x is equal to x n minus 1 plus h. The process is continued till this absolute value is less than or equal to assigned accuracy. You will be asked to find the number of approximations. You will be asked to find 3 approximations. You will be asked to find 4 approximations, 5 approximations. So now from here, if you are asked to find 3 approximations, so you will be able to find y1 by putting n by 1, replacing n by 1, by 2 and by 3. If you want to find the fourth approximation, then you need to replace n by 4, so you'll get the fourth approximation. To understand the idea of Picard's method, let us take an example. In this example, we are asked to use Picard's method to solve a differential equation, this differential equation y prime is equal to x plus y square, and subject to the initial condition y naught is equal to 0 and x naught is equal to 1. You see that y prime is given to you people, and initial approximation or initial guess is given to you people, and you need to find solution of this differential equation by using Picard method. and you need to find 3 approximations. So we need to find 3 approximations. So we need to find y1, y2, and then y3. So let us start solution of this question. Given that y prime is equal to x plus y square, but we also know that y prime is actually function of xy, because this equation contain x and y, so this is the function of x comma y. So y prime is equal to function of x comma y, that is given to you people, x plus y square. That is the first thing. And secondly, the initial approximation x naught and y naught is also given to you people. These two steps are very simple, that is taken from this question. And the third step is to use the general formula of Picard's method. So that is the general formula of Picard's method, which we have studied recently, and we need to find 3 approximations from this formula. So for first approximation, we need to put n is equal to 1 in this equation. So whenever you put n is equal to 1 in this equation, you'll get y1 is equal to y naught plus integral from x naught to x function of x comma y power 1 minus 1, because n is equal to 1 and 1 minus 1 is 0. So that is y naught. So that is the first approximation, y1 is equal to y naught, and we know that y naught is 0, so we have replaced y naught by 0 from here, and from there that is actually y naught, the same y naught is there, but we have written 0 and the superscript of y. You may also write this 0 and subscript of y, that is the same. I mean, these two have the same meanings, so that is actually y naught, and y naught is given to you 0, so we have replaced this y naught by 0. So that is function of x comma 0. Now what is function of x comma 0? We need to replace function of x comma 0 here, and that will be obtained from this equation. So from this equation you see that function of x comma y is given to you x plus y square. So function of x comma 0, replace y by 0, so x comma 0 is equal to x plus, we have replaced y by 0, so that is also 0 square. X plus 0 square is equal to x, so function of x comma 0 is actually x, so that is x. So that's why a function of x comma 0 is x. Now we need to find the integral of x, and we know by the formula that integral of x power 1 is x power 1 plus 1 by 1 plus 1, so that is x power 2 divided by 2, that is the integral. And put a straight line on the right hand side and put these limits from 0 to x. First of all, we need to upper limit in this portion, so replace x by upper limit, so you need to replace x by x, the same thing, so that will be x square by 2. Then minus replace lower limit in instead of x here, so that will be 0 square by 2, 0 square by 2, 0 square by 2 is 0, so that is x square by 2, so it means that 0 has nothing else here. You just need to write this fraction over there, so that is x square by 2. So the first approximation is x square divided by 2. Now we need to find the second approximation, and for second approximation we need to put n is equal to 2 in the Picard's formula. Whenever you replace n by 2, so the left hand side will become y2 is equal to y naught plus x naught integral from x naught to x function of x comma y power n minus 1. So n minus 1 means 2 minus 1, so that is 1. So that is function of x comma y1. So y1 is actually the first approximation, which we have obtained recently. Y1 is x square by 2, which we have obtained in the first approximation. So we have replaced y1 by its own value, which is x square divided by 2. So that is function of x comma x square divided by 2. Now we need to find the integral of this function. Now what is the value of f of x comma x square divided by 2? We know that function of x comma y is x plus y square. So here we see that y is replaced by x square divided by 2. So replace y by x square divided by 2 here, and the same replace y by x square by 2 there, and this is whole square. Now open this square, so that is x power 4 by 4. So x plus x power 4 by 4, that is the value of this function. Function of x comma x square divided by 2 is actually x plus x 4 by 4. So that is x plus x 4 by 4. Now we just need to integrate this sum. Integral of x is the same thing. Integral of x is x square by 2, and integral of x4 by 4, integral of x4 is x5, x4 plus 1, x5 divided by 5. So integral of this portion is x5 divided by 5, but 5 will be multiplied by 4, so that is 5 4s are 20. So that is x5 divided by 20. That is the integral of x4 by 4. Now we just need to replace these limits 0 to x, replace x by x here, and that is the same thing. 0 has nothing else here, because if you replace x by 0 here, so that will become 0. So just write this whole function over there. That is the second approximation. Remember that. And the last one is we need to find the third approximation, and for third approximation we need to put n is equal to 3n pi cars formula in equation number 1. So whenever you replace n by 3, so that side will become y3 is equal to y naught plus integral from x naught to x function of x comma n minus 1. This is n minus 1, n is equal to 3, so that will become 2. So function of x comma y2, but what is y2? That is actually the second approximation, and second approximation is x square divided by 2 plus x5 by 20. So replace y2 by x square by 2 plus x5 by 20. Now in the same manner, from here we see that function of x comma x square by 2 plus x5 by 20 will be obtained from here. We see that y is replaced by x square by 2 plus x5 by 20. So replace this y by x square by 2 plus x5 by 20 here and there, that is x, and this y is x square by 2 plus x5 by 20, and this is whole square. Now open this sum, a plus b whole square is equal to a square plus 2ab plus b square. So this is actually function of x comma x square by 2 plus x5 by 20. Replace this function by this value. So whenever you replace this function by this value, you just need to find the integral of these four terms. Integral of x is x square by 2, integral of x4 by 4 is integral of x4 is actually x5 by 5, and x5 by 5 and 5 into 4 is 20. That is x8 by 8, and 8 into 20 is 160. That is x11 by 11 multiplied by 400 is 4400. So that is the integral of this whole function, and put the limit on right hand side, and just write this whole function over there. That is the third approximation by using Picard's method of this of the given differential equation. So this is the approximate solution of the given differential equation with the help of Picard's